Hello, this is Tom Nahumi from DELL EMC XtremIO, and today I'm going to show a demonstration of consolidating and protecting virtualized enterprise environments using DELL EMC XtremIO X2, DELL EMC RecoverPoint 5.1, and VMware Site Recovery Manager. As you can see, I have two vCenter servers in a shared SSO domain, production and DR. Each one connected to a dedicated XtremIO X2 single brick. The production environment contains 8 intensive I/O virtual machines which resides on XtremIO X2 data store. These machines will be replicated to the DR cluster using DELL EMC RecoverPoint 5.1 and will be protected using VMware Site Recovery Manager. Now let's take a look at our storage arrays. In this setup we have two X2 bricks. XBrick 5115 is the production array and XBrick 5110 is the DR array. We can see that the virtual machines generate approximately 230k IOPS and about 1 GB bandwidth, when the bricks serve the load in less than 0.6 millisecond latency. Looking at the configuration tab of the production array, we can see that we have 10 VMFS data stores, source RecoverPoint repository LAN which contains the data of the production RecoverPoint cluster, and a placeholder LAN which contains the Site Recovery Manager configurations. The DR array has only target RecoverPoint repository LAN which contains the data of the DR RecoverPoint cluster, and a placeholder LAN which contains the Site Recovery Manager configurations. From the RecoverPoint storage tab, we can see that our production XBrick and the production vCenters are connected to the source RecoverPoint cluster, which is RPA SC4B, and our DR brick and the DR vCenter are connected to the target RecoverPoint cluster, which is RPA SC4A. So now let's go through the process of creating a new consistency group and take a look at the new capabilities of RecoverPoint 5.1. So with that, I need to go to the Protection tab and click on Protect Volume. Here I can see a list of XtremIO volumes which are mapped to the source RecoverPoint cluster. Let's give this consistency group a name and the production name and select the volume we want to protect on. As for RecoverPoint 5.1, it is possible for RecoverPoint to automatically provision a journal volume for an XtremIO based copy. RecoverPoint would create a volume on the relevant XtremIO array and assign it to the appropriate RPA initiator group. The provisioned volume would be 2 GB of size and would be only provisioned if there is no journal volume assigned to the copy already. A new capability introduced in RecoverPoint 5.1 is the ability to automatically match selected production volumes to exposed replica volumes. Selecting this option will automatically provision those copy volumes for me at the DR site. Here, I can set the replication mode. For the purpose of this demo, I just leave it with the default of 90 seconds and choose the periodic. If XtremIO is at a production copy, then snap-based replication will be automatically configured for periodic mode with 1 minute interval. This can be changed on a per link basis or via editing the link policy during consistency group creation or after it has already been created. Clicking Expose Volumes to Initiator Groups opens a pop-up screen displaying a list of the available initiator groups. The list enables us to expose new auto-provisioned volumes to a specific host. By default, no initiator group is selected. Here I'm going to select all of my ESXi servers at the DR site. Here I'm selecting automatically provision a journal volume for the XtremIO based copy. RecoverPoint would create a volume on the relevant XtremIO arrays and assign it to appropriate RPA initiator group. When I click Finish, RecoverPoint will start the replication of the production data store we chose to the DR site. Looking at the production brick, we can see that the journal LAN has been automatically created and mapped to the source RPA cluster. In addition, an XtremIO snapshot has been taken from our replicated volume. Looking at the DR brick, we can see that the replication has been started and RecoverPoint is replicating the source data store to the DR brick. We can see that the journal LAN has been automatically created and mapped to the target RecoverPoint cluster, and in addition, we see the XtremIO snapshots which have been replicated from our protected volume. In order to obtain higher throughput rates, it's possible to configure the consistency group as a distributed consistency group. This consistency group offers better performance than non-distributed, as they run on a minimum of 2 RPAs. After the consistency group has been created and SRM has been installed, the consistency group needs to be configured to be managed by SRM. This is done in the RecoverPoint management console as well. Selecting the consistency group, which is going to be protected by SRM, and go to Group Policy tab to adjust the setting. Registering VMware vCenter with RecoverPoint creates a connection between RecoverPoint and the virtual environment, which allows RecoverPoint to display the VMware view of the virtual machines configured for application. We can see that WebApp 001, which resides in CG01, is fully protected, while vMprod virtual machine is not configured for application and therefore not protected. Now, let's configure the DR procedure with SRM. VMware SRM is a plugin to the VMware vCenter, so disaster recovery tasks can be executed from the same centralized interface that is used to manage the virtual machines, such as creation, migration, and deletion. We can see that both sites are configured from the Array-Based Replication tab. We can see that SRA is installed in both sites and the replication direction for the protected volume. For this solution, a single protection group was created to fail over the 8 production virtual servers. Multiple protection groups could be created as long as the protection groups match the number of RecoverPoint consistency groups that are managed by SRM. After entering a name, we select the protection type and the protected volume. Then, we get a list of the virtual machines which reside on this data store. Then, click Finish to create the protection group. We can see that vCenter creates the shadow VMs at the DR cluster on the placeholder data store we created earlier. SRM Recovery Plan is an automated plan for recovering protected virtual machines at the DR site. After specifying a name and description, we select the recovery site in which the VMs will be recovered as part of the recovery plan. Next, we select the list of protection groups will be included as part of this recovery plan. On this tab, we can specify the test networks to use while running the test in the recovery plan. We can manually select these test networks if we have created them for test purpose, or we can leave them with the default auto-created test networks called isolated network. Let's click Finish to create the recovery plan. At this point, we are ready to run a failover scenario. Going back to the RecoverPoint UI, we can see that the initial replication has completed successfully. By default, SRM only allows you to fail over to the last point in time. The combination of RecoverPoint and DELL EMC VSI plugin offers administrator an extremely powerful tool in relation to BCDR planning activities. As long as VMware SRM is tasked with the management of RecoverPoint consistency group, System Administrator will have the ability to specify a specific point-in-time copy used during the SRM test recovery plan or disaster recovery scenario. This means that system administrators can actively assign what point-in-time instance of their protected datasets are brought online at their secondary sites. What I'm going to do now is creating a manual bookmark called Tomer Point-in-Time. Going back to the vSphere web client to the data protection systems, I see that RecoverPoint and SRM are already registered with the vCenter server. At this point, all I have to do is going to one of the virtual machines which reside under the consistency group I created under the EMC VSI tab and select the point in time I manually created. In the next failover scenario, SRM will use the specific point in time I selected. At this point, we are ready to perform a failover scenario. We go to the recovery plane and click on Failover button to start the process. Looking at our X bricks, we still see the load on the production brick. In the following minutes, SRM will shut down the VMs at the production site and recover them at the DR site. Here, we can see that the shutdown process completed successfully and SRM is powering on the VM at the DR site. If we go to the Summary tab of one of the virtual machines and click Open Console, we see that this machine is already up and running. Now, let's take a final look at our storage arrays. We can see that all of our production machines are running at the DR site and generating load on the DR brick. I hope you find this information useful and thank you for watching.